Okay, we're going to look at combined gas laws. Now, we did the three gas laws. Well, there's more than that, but the main three gas laws are Boyle's, Charles, Avogadro's. So this one is comparing. If we look at PV equals nRT, we have three values changing. We're starting with volume, so the volume is changing from 106 to something we don't know. So volume is changing. The temperature is starting at 45 degrees Celsius and it's going to change to 20 degrees Celsius. So the temperature is changing. And the other thing that's changing is pressure, 740 mmHg, and that's going to change to 780 mmHg. And once again, this is just another unit of pressure. Don't worry about what it is. We're just going to do the math. So those are the three values that are changing. So as far as combined gas laws, we have to come up with an equation. You can kind of combine them. This is going to be, I'm going to show you how to kind of just do it, and then I'm going to show you like the mathematical way to really do it. So I have P and V, and if I look at Boyle's law, that was P1 V1 equals P2 V2, remember? And if I look at Charles' law, that was V1 over T1 equals V2 over T2. Okay, so can I kind of put these together? The P and the V get multiplied, the T gets divided by the V. If I kind of just smush them together, I know this is going to, and there's not really any math behind this method, it's P1 V1 over T1 equals P2 V2 over T2. So this is the law we're going to use. How can we do that mathematically? Let's go back over here. So just like before when we were doing these, anything that was changing, which are the three that I have underlined, we push to one side. Anything that was not changing, which is the N and the R, we're going to kind of leave over there. So all we have to do is get this T over to the other side with the P and the V. And the way we're going to move that is by dividing it. So divide by T on both sides. Here they cancel, and we end up with PV over T equals NR. And remember, N and R in this case, or in this scenario, are not changing, so we can ignore them. And so we create this to be P1 V1 over T1 equals P2 V2 over T2. Okay. So if you can look at them, and sometimes it's easy, if you can kind of look at the formulas and just smush them together, that's great. You can't always do that, but this one kind of works out nicely. If you can't just smush them together like I was saying, then we want to kind of do it this way. And you want to push everything that's changing to one side, and anything that doesn't change, you push to the other side. All right, so what can we do here now? Well, let's do some solving. So we have our formula. Let's go back to the actual problem here. All right, so P1, V1, T1, P2, V2, T2. All right, here. Let's see. So volume of 106.0 liters. 106.0 liters. When the temperature is 45 degrees Celsius and the pressure is 740.0 mmHg. Okay. Those are our initial conditions. What will be its volume? Question mark. At 20 degrees Celsius, so now the temperature is going from 45 to 20, and 780.0 mmHg. All right. Okay. So first thing, you have to remember this. We cannot do any calculations while our temperature is in Celsius. It must be in Kelvin. So if you remember to turn this into Kelvin, all we do is take Celsius plus 273. So plus 273 is going to be, let's see, Ugh. Oh, sorry. Okay, 273 plus 273 plus 20 is going to be 293. That's easy enough. 293 Kelvin. And 273 plus 45. Let's see, 313. 318. 318 Kelvin. Okay? All right. Now we're just going to plug in all the values in that formula that we wrote down, and we're going to do this just like we did before. So it's P1 times V1 divided by T1. So pressure times volume over T, and pressure volume over T. So 740.0 mmHg times 106.0 liters divided by 318 Kelvin equals volume 2 is our question mark. Pressure 2, 780.0 mmHg divided by 293 Kelvin. Now something like this is way more realistic because in a perfect scenario it's actually very uncommon for just like two values to change. More than likely when you're looking at one of these closed systems, the pressure, the volume, and the temperature will change. So like I said, this formula is definitely your most common. Alright, so now all we're going to do is cross multiply and divide just like we did before. So cross multiply 293 times 740 times 106. Let me grab my calculator. So 740 times 106 times 293 equals, whoop, big number, 22,982,920, 22,982,920. So that's this times this times this, they're diagonal, equals this times this times this. Now obviously this is our variable, so just 318 times 780 equals 318 times 780 equals 248,040 V2. All right, so just like any equation, how do we get V2 by itself? We're going to divide 248,040. Cancels out. V2 is equal to, oops, sorry, moving this around a little bit. Let's see, 22,982,920 divided by 248,040, and I'm getting 92.7 liters because this is volume. Volume started with liters, volume is going to end with liters. 92.7 liters. All right, there it is. So the thing is, because before when we were able to do these, you had something increasing and something decreasing, so you kind of knew what your final answer would be. In this case, the pressure is increasing, which means the volume should decrease. But here, the temperature is decreasing, which also means the volume should decrease. So sometimes you can't actually know, but sometimes and other times you won't be able to figure it out just by looking at it. You have to do the math. This one we could have actually figured out before we started. Anyhow, sometimes you'll know the formula, sometimes you'll have to create it. Either way, make sure you always write down all of your steps. You should be able to kind of figure it out after that. All right, go online and check out the questions I have for you guys, like always, and that's about it. Have a good day.